Hello, and welcome to our program, Astronomy for Everyone. Last year saw the end of the U.S. Space Shuttle mission after 30 years. We thought it would be a good time to take a look back at this program to review some of the highlights and lowlights. With me here in the studio today to talk about the U.S. Space Shuttle mission is Steve Whitty. Steve? We've got a lot of material to cover in about 22 minutes.
Yeah, there were 135 missions, and it covered 30 years. So, yeah, we got to get going.
All right, so what's first?
Space Shuttle Enterprise. Space Shuttle Enterprise didn't fly in space. This was a drop test article. So what they did was they put the Enterprise, it looks like a shuttle. They put it on top of a 747. They did capture-carry tests where they were testing the aerodynamics, but while it was still on the 747. So they were flying through the air with the Enterprise attached. So after doing a few flights in a capture-carry test, they did drop tests where the 747 would arc over and the Enterprise space shuttle actually separated, and then the pilots would land the shuttle on its own, basically a glide test. And they did 5 of these drop tests, and in the last of them they discovered a problem, a pilot-induced oscillation, they call it. And they had to fix this before they actually launched into space. It led to modifications to the shuttle design.
And from there we started off with the real flights?
It was, so the Enterprise flights were from 1978 to, I think it was 1980. And then in 1981, Columbia was the first flight, right? So Enterprise was intended to launch, to be turned into a craft to launch into space. But it turned out that the modifications necessary in order to make it spaceworthy were more costly than going a different route. And they never did change Enterprise into a spaceworthy vessel.
So from there we had our first shuttle with Columbia, and then the program moved forward.
Right. So Columbia did 4 flights with just a pilot and a captain, where they went into space and they came back. Most of the shuttle flights had 7 crew members, pilot and a captain, and then 5 crew. There was a Challenger flight with 8 astronauts on board, and there was another flight as well with 8. But mostly you had either 5 or 7. You either had 7 crew or you had 2. The last flight also had 4 for weird reasons. Atlantis, on its very last flight, only carried 4 astronauts because if they had a problem like Columbia did on launch, then their abort procedure was to stay at the International Space Station. The astronauts would just stay there. And they had a logistics problem. They wouldn't be able to get everyone off if they had 7 people aboard the shuttle.
Good prior thinking there, just in case.
Yeah, there were a lot of interesting little quirks to the missions.
So then how does the program move forward from there?
Then they started adding more capabilities, and they had more people on board each flight. They did a lot of different things. If I tried to list all of the flights that had life sciences, or there were a couple science modules, Space Hab and Space Lab. If I tried to list just those, then we'd be here all day. So most of the flights did these things. But they also did some interesting things where they went into space, they captured a satellite, a commercial satellite in a couple cases, where they wanted to fix the satellite. So if a satellite had failed in orbit and they wanted to fix it. And so one of the satellites, it was.
Is that one of the Landsats?
My memory is a blank. SolarMax, right, SolarMax. So SolarMax was actually brought back into the shuttle bay, and it was returned to Earth. It was then refurbished and then relaunched. Intelsat 6, they went up into space. They captured Intelsat 6. They stopped it from rotating. They put a booster on it, and they got the satellite back into the intended much higher orbit. So there was these were capabilities that we were interested in.
Okay.
We didn't use them very much, but we did demonstrate that we could do these things.
Interesting. So where else did we go with the shuttle program? Some of the flights themselves, some of the other craft?
So we launched the Hubble Space Telescope, the Compton Gamma Ray Space Telescope, the Chandra X-ray Space Telescope. We also launched Galileo, which went to a space probe that went to Jupiter, Ulysses, which went into solar orbit almost out as far as Jupiter, and Magellan, which orbited Venus.
Well, in addition, we also used the space shuttle to repair Hubble.
That's right.
On several occasions.
There were five servicing missions for Hubble, and Michigan-born astronaut Andrew Feustel was part of the fifth and final servicing mission. So he talked to us at Astronomy at the Beach in 2008, and a year later he went up and did the final servicing mission. So it was great to talk to him back then.
Yeah, it'd be great to hear his comments having been back from doing that. Maybe we'll get him at Astronomy at the Beach.
In the future,
In the future.
Yeah, that would be awesome. Yeah. Let's see. So a typical shuttle launch, so we talk about the shuttle. You know, you've got the shuttle, right? Mm-hmm. But what launches is the shuttle, the two solid rocket boosters, and the on the diagram, the orange fuel tank. It was the external tank. Now you think of the external tank as being, oh well, it's just sort of attached to the shuttle, but it's really the reverse. The shuttle and the solid rocket boosters were attached to the fuel tank. The fuel tank was the big structural member that held everything together. So the fuel tank had hydrogen and oxygen, which fed the shuttle's main engines, and so there were three main engines on the back of the shuttle that helped power the whole stack up into space. The solid rocket boosters provided about 85% of the thrust necessary to get up into space. So once you've gotten the whole stack is on the ground, you light the candle, it goes up into space. The solid rocket boosters are ejected first, and in fact there are little tiny rockets that push them away from the rest of the shuttle. And then the shuttle with the fuel tank then continued to orbit. And the fuel tank, in fact, makes it all the way to orbit. We talked about using the mass of the fuel tank for some projects, maybe a space station or something, but we never did that. The external tank was designed to break up on reentry, so it would basically burn up and fragment into little tiny pieces.
So the only reusable part of the whole space shuttle package was actually the shuttle itself that held the astronauts.
Well, the solid rocket boosters were also reused.
Oh, okay.
So what happened was the solid rocket boosters had parachutes, and they landed in the Atlantic Ocean. So they would then be refurbished, they would be refueled, and then they would be reused for further flights later on.
It's great to see NASA doing a little bit about reduce, reuse, and recycle.
Right. So really, it was only the external tank which was not reused.
Very interesting. Very interesting.
So, yeah.
In about the minute that we have left in this first segment, anything else you'd like to let our audience know about?
Yeah, so the shuttle is is just about making it to orbit. It turns out that when the solid rocket boosters leave, the main engines don't have enough thrust to accelerate the shuttle. But as fuel is consumed, that changes into increasing speed. So there is kind of a weird spot there where the shuttle is slowing down on its way up. The whole trip into space takes 8 minutes. It's very fast.
From launch pad to orbit.
From launch pad, when you're going 0 miles per hour, to you're in orbit at 17,500 miles an hour. You have to go that fast, otherwise you come back down.
That wouldn't be a very good thing.
It's not what you wanted to do, no?
Nope. No, not putting any of those people in jeopardy. Well, we hope you've enjoyed this first segment here in our talk about the U.S. Space Shuttle Program. We're going to take a quick break and go to Term of the Month with our own Steve Whitty. If you have a question, please send us an email. We'll be glad to respond to those questions on this topic or really anything else. Don't go away. We'll be right back.
The term of the month for February 2012 is stellar evolution. Last month we talked about how stars can form from a nebula of gas and dust. And this month we continue in with the life cycle of stars. So you have the nebula, parts of the nebula will collapse gravitationally and a star forms. From there it depends on how much mass goes into a star. If you have only a little bit of mass, then if you have only, for example, 8% of the mass of the sun, then you can't even burn hydrogen. You have a fairly short-lived star that burns deuterium for a while, and that's it. From about 8% and on, you have a red dwarf that burns hydrogen into helium, but it at the end of its life, it simply cools. These stars can last trillions of years. The sun is about halfway through its 10 billion year lifespan. At the end of its 10 billion years, it will expand to a red giant, which will be almost the size of the orbit of the Earth, which is not good for us. And then it will fluff off the outer layers into a nebula and become a white dwarf. Next month, we'll talk about bigger stars. This has been Term of the Month, Stellar Evolution.
Welcome back to our program. We're in a discussion here with Steve Whitty about the U.S. Space Shuttle Program. And we're back now to finish up this lively discussion. Steve, where do we go to now?
Well, we left our astronauts in space, so let's leave them in space for just a little longer. One of the destinations, especially later in the program, was the International Space Station. So the shuttle would dock there. You may not remember, but the space shuttle, there were 6 space shuttle missions to the Russian Mir space station before the International Space Station. So there were these destinations. With the shuttle docked to the International Space Station, the shuttle could draw electric power, if necessary, from the solar panels of the space station, and you could stay up there for quite a while. Normally, the shuttle had a duration, had an endurance limit of about 17 days, and the record was, in fact, Columbia on a 17-day mission. Curiously, Columbia itself could not dock with the International Space Station.
Why is that?
Columbia was the first of the orbiters, and it was also the heaviest. As engineers gained experience with Columbia, they trimmed the design down in a number of ways. So the later shuttles were progressively lighter. And as they were lighter, they could either carry more payload or they could actually climb higher into space. So yeah, Columbia didn't ever go to the space station.
Interesting fact. I wasn't aware of that.
Yeah. So astronauts would go outside and they would do things. They grappled with the satellites, as we mentioned before, but also they would work with experiments that were outside. So there was the long-duration exposure facility that they deployed, and this was basically a pallet that had a bunch of things and they wanted to know how these things survived in space. And they had different materials, some aluminum, some various thermal tile type materials, but they also had biological samples. And this facility stayed in orbit for quite a while, and then a different shuttle actually picked it up and brought it down to the ground.
So this way they could do their experiments out in space and then bring the results back down to Earth to be studied.
That's right. That's right. Yeah. So, so once you've done stuff in space, well, all right. So the shuttle can do a whole bunch of things in space. They did numerous medical experiments. So the astronauts are the guinea pigs, if you will. They're getting blood tests all the time, and they're getting bone density tests for for how weightlessness affects them, and so on. And the shuttle was an interesting place, as it was a new place where you had more of the comforts of home than you had on the previous, especially the previous U.S. missions. The amount of working area that you had, even in the Apollo capsule, wasn't anywhere near as large as you had in the Space Shuttle.
Space Shuttle had a galley, it had a bathroom.
So it had a real bathroom for the first time. It had a real galley where you could make real meals. And there was the feeling that you had the payload capacity to maybe not live it up, but at least do a little bit better. So when you're done with your mission, then along with the 3 Space Shuttle main engines, well, they don't have any fuel anymore because you've gotten rid of the external tank. They also had something called the OMS engines, and these engines were used to deorbit the Space Shuttle. So you have to slow it down, and the idea there was that you would point the shuttle backwards, because you have to have the engines facing, in the direction that will slow you down. Right? So you'd point the shuttle backwards, you'd fire the engines for about 3 minutes, and you would change the orbit of the shuttle so that it now intersected the atmosphere. You'd then flip the shuttle over again so that it's pointing nose first, so that when it hits the atmosphere, it has the heat shield, which is the big black nose on the front of the shuttle, and the bottom of the shuttle basically hitting the atmosphere first. So it's atmospheric drag that slows the shuttle down. And in fact, they would do these big S-turns. They would do like 5 big turns on their way down to increase the drag, so that they were doing sort of sideways. They would have sideways forces rather than sort of straight down forces as part of the way that they slowed the whole vehicle down.
So they used the atmosphere as a giant brake.
That's right. That's right.
Sort of a controlled descent, much like a sailplane.
Right, and the idea is that if you tried to do it with rockets, then you'd have to bring up all of the rocket fuel needed to do that. So it's the rocket fuel would be very heavy. You'd have to bring it up into space, and it would limit what you could carry on the way down. Atmospheric drag is great for that. So when you're coming in for a landing, originally, shuttles landed, basically they would put their gear down in preparation for a landing, and then they would strike the ground, and they would just roll out. In later years, they added a drag parachute. So if you see like this image where you have a drag chute, that's a later flight. So the Space Shuttle system was constantly upgraded and changed, and so you'd say, well, this orbiter made 38 flights. Well, yeah, it's this orbiter, but it's this orbiter upgraded probably 15 times. So one of the upgrades that I remember was the main computers were upgraded. Well, the main computers weren't very fast, and they were very large and heavy. And the original ones used something called magnetic core memory. And they were upgraded. The new machines were 3 times faster. They had a lot more memory. They used semiconductor memory instead. They were also 1,000 pounds lighter. And that meant that you could bring 1,000 pounds of something else up into space. And there were other upgrades that allowed more stuff to be brought up.
With our program having come to an end, these ships are still there. I understand that various museums and other locations around the country were looking to acquire one for their facilities.
Yeah, I got to see Enterprise at the National Air and Space Museum near Washington, D.C. The Enterprise is going to be moved to New York City. The National Air and Space Museum is going to get one of the 3 flight articles. Another is going to California, and the third is going to Kennedy. Yeah, that's right. Obviously,
they should have one. I mean,
they should have one.
Yes,
yeah,
yes, they should.
And they will. Yeah,
it's been their business for the last 30 years.
Right. So there was a set of bids, and institutions had to bid on transporting the craft to their site and refurbishing them so that they would be viewable. Basically, they would be, they wouldn't have dangerous chemicals. They wouldn't have certain things on them. And it was something like $28 million that you needed to pony up before you could have your own shuttle.
That's quite a bit of money.
It was more than I could afford.
Really? Now, when they landed the shuttles, did they always come back to the same location?
No, actually, there were a number of places that were designated landing places. On launch, if various things had gone wrong, there were landing sites. One of the ways that they could have landed was they could have landed right back at essentially the launch site, do a quick loop and come down. That was never done. There were a lot of places that were never used. There was a landing strip in Spain, for example. If they made it across the Atlantic but not into space, they might have to land there.
Most of them happened at Edwards?
Well, most of them happened in Florida, near the launch site, after the mission was over. And that was the preferred way of doing it, because if you didn't do that, if you landed at Edwards or at White Sands, New Mexico, then you had to put the shuttle on top of the 747 and ferry it across the United States.
So those extra transportation costs to get the shuttle back.
It was about $1 million to ferry the shuttle from California to Florida using the 747. You had to do multiple trips. It usually took about a week. So you would put the orbiter on top of one of the 2 747s. You would do a short flight. You had to do at least 3 flights in order to make it across. You would have to refuel the aircraft, but you would also have to wait for the weather to be good and for the entire flight. So you had to. We were very careful about these. So.
I understand there was a little inside joke with the 2 747s. Up on the top, they had the spot where it said, "Put Space Shuttle here."
Yeah, it was very funny. They had a little bit of humor right on the 747, and there was also a note that said "black side down." They were talking about the black underside of the space shuttle. Just make sure you put it on right.
Who said rocket scientists don't have a sense of humor?
Yeah, absolutely.
Well, I'd like to thank Steve Woody for being with us here today to talk about the U.S. Space Shuttle Program. It seems like 30 years went by in about a week, at least to me anyway. If you'd like to have more information about this program, about the Space Shuttle, or anything else we do here at Astronomy for Everyone, please visit our website. You can see the address down at the bottom. And right after this short break for a scroll of upcoming astronomy events here in Southeast Michigan, coming up next is John Schroer with What's Up for February.
What's up for February 2012. We'll start the month with a full moon on the 7th, about 5:48 in the evening. The third quarter moon will be on the 14th, close to lunchtime, around 12 o'clock, while the new moon will be on the 21st of February at 5:35 p.m. The first quarter will be at the end of the month on the 29th. First, the planets in the sky will start with Mercury. Now, at the beginning of the month, Mercury won't be visible because on the 7th, it'll be in conjunction with the Sun. By the end of the month, it'll be high enough to be seen in the western sky, low to the horizon. Next, we'll start with Venus. Venus will be low in the sky in the west at the beginning of the month. By the end of the month, it'll be much higher in the sky, in fact, getting close to the planet Jupiter. Jupiter will be next visible in the south by southwestern sky near Pisces and Aries the Ram. On the 26th, you'll be able to see it with the crescent moon. We also move on to Mars. Mars will be up after midnight in the eastern sky near Leo the Lion. You'll see it here next to just past the full moon, near the middle of the month. Saturn is the last planet you'll be able to see in our night sky, and that'll be in the morning sky around 6 o'clock next to the bright blue star Spica in the constellation of Virgo. Finally, we want to give you an update on Comet 2009 P1, Gerad. It will be visible in Hercules, and on the 12th of February, it will reach its max brightness, according to predictions, magnitude 7. Here you can see a chart. It's not far from the Great Globular Cluster M13, the one in Hercules. That's What's Up for February 2012. Have a great day and enjoy your night sky.